Before we start on the Pythagorean theorem, let's do a really brief overview of classifying triangles by their angles. So remember, there are three types of classifications according to the angles of triangles. First one is, this is the part of the job that I hate because I have to draw. First one is an acute triangle, meaning that all of these angles, okay, 1, 2, and 3, all three angles are acute angles. Acute angles mean that they are less than 90 degrees. Okay, so this is an acute triangle. All angles are less than 90 degrees. Then we have an obtuse triangle. Okay, let's say that this angle was 100, and this one was 50, and this one was 30. Remember, all triangles have 180 degrees. This is an obtuse triangle because one angle is between 90 and 180 degrees. Okay, it cannot be 90 or 180 degrees to be an obtuse triangle. It has to be between 90 and 180. And then finally, we have a right triangle. This little square, I'm going to do in a different color. Let's do green. This little square inside of it identifies that there's a 90-degree angle right there. This is a right triangle, where one angle is exactly 90 degrees. Now for the Pythagorean theorem, we're going to be talking specifically about right triangles. Okay, the Pythagorean theorem only works for right triangles. Now some of you have already been exposed to the Pythagorean theorem because of a goof up by me when we were dealing with 2D geometry. Great, I'm glad you figured it out. I'm glad you learned it. So let's talk about the Pythagorean theorem now. So this is a right triangle. We know that this is a right triangle because it contains a right angle. And we know that this triangle specifically contains a right angle because I just put that box there and I identified it. Okay? Anytime you see this little square right here, it means that it's a 90-degree angle. I don't need to tell you it's 90 degrees. This square tells you that. So moving forward, anytime you see this little square inside of a triangle like this, where an angle is, it identifies a 90-degree angle. Please do not ask me what that means moving forward. I'm not going to tell you. It's in the video. It is in your lesson. Okay? You should know this. Please take notes. So about 2,500 years ago, a Greek mathematician named Pythagoras presumably discovered a special relationship between the sides of right triangles. He found out that if you take three squares, okay, we're going to call them square A, square B, and square C, and you position them in a way that you create a triangle, okay? Not just any triangle, but a right triangle. He found out that the area of square A plus the area of square B, if you add these two red squares together that make up this right angle, it equals the area of square C. Okay? And as a result, he figured out that square C is equal to the areas of square A plus square B, which is where the Pythagorean theorem comes from. So let's say that we have this example down here. Don't worry about the words right now. We know that square A has sides that are 8, meaning all of them are 8 because it's a square. B has sides that are 6, and all 4 of them are 6 because it's a square. All sides are equal. We do not know the sides of C. Okay? So what did Pythagoras discover? He found out that in order to find out the area of this circle, and then later to find out the sides, he could take the area of A plus the area of B. Well, to get the area of a square, it's length times width. And since the length and the width are both 8, you get the area of square A by multiplying 8 times 8, which is 8 squared, which equals 64. And then the area of square B, okay? The area of a square again is length times width, 6 times 6, or 6 squared. That gives you 36. Now remember, I can add these up and it's going to equal the area of this blue square. So 64 plus 36. That gives me 100. That means the area of this square, this blue square C, is 100, whatever my units are, squared, okay? But how long is each side of square C? What do we need to do to figure that out? Well, if you know that it's length times width, and you know the length and the width are the same thing, meaning you have to multiply them together, then guess what happens? Let's do this. So we did 8 times 8, which was 8 squared. And we added that to 6 squared, which gave us 64 plus 36. That told us that the area of square C is 100, whatever my units are, squared. Well, if I know that to get the area of square C, I have to multiply length times width. And if I know that the length and the width are the same thing, I'm just going to call them sides now. So let's replace this. Remember, the sides are all the same, side times side, which is side squared. That means that if I'm looking at C, this is a side, this is a side, side squared equals 100, because we already found out that the area was 100 over here. Well, how do I figure out what squared equals 100? Well, I just have to undo this. This is another way that we solve equations. I have to get the square root. If I get the square root and the square cancel each other out. S equals the square root of 100, and we know that the square root of 100 is 10, because 10 times 10 gives me 100. So that means that every side of this square is 10. Okay? And we did that by solving for the area of A of square A plus the area of square B. And that gave us the area of square C. So Pythagoras realized that if you have a right triangle and you square the lengths of the two sides that make up the right angle and add them together, then you end up getting the same number you would get by squaring the other side. Okay? So it's just like what we said right here. If I rewrote this This is the same thing as me saying 8 squared, which is here, plus 6 squared, which is here, equals, well, 100 is the same thing as 10 squared, okay? Again, Pythagoras found out that if you square the side of one of the angles that makes up a right angle, or one of the sides that makes up a right angle, and square the other side that makes up that same right angle, and you add them together, so in this case 3 squared plus 4 squared, it gives you this longest side squared. And this works every time as long as the triangle is a right triangle. So let's talk about some vocab. And you should know what these mean because I am going to be using these. I might not give you an actual drawing of a triangle. I might tell you that the legs are certain lengths. So understand this. The legs are the two sides that come together to create a right angle. Okay? So see how this side and this side create this right angle. And I know again that it's a right angle because of the square inside. This identifies that it's a right angle. These sides are called legs. Okay, the legs hold up the right angle. The lengths of the legs are going to be referred to as A and B in our general formula for the equation of the Pythagorean theorem. Okay, so we're going to label the legs A and B. And right across from the right angle is what we call the hypotenuse. Okay, it's the hypotenuse. It's not the hippopotamus, it's the hypotenuse. Okay, I know it's a funny word every year. People laugh, haha. Anyway, so the hypotenuse is always the longest side, and it's always going to be the furthest away from the right angle. Okay, it's the one that's not touching or creating the right angle. It's the one directly across. And again, the hypotenuse is always going to be your longest side. So a good way to check after you've done the Pythagorean theorem is to make sure that this side is actually longer than either of the two legs. Okay, it always has to be the biggest one. And we usually label the length of the hypotenuse as c. Okay, these are the variables that stand for the legs in the hypotenuse. A, B, and C. The relationship that Pythagoras discovered is now called the Pythagorean theorem. Basically, it says that a squared plus b squared equals c squared. So if I take the two legs, a and b, and first I take a and I square it, and then I take b and I square that, and add them together, their sum is going to equal whatever c is squared. Okay? Now, if you're asking me, does it matter which leg I label A and B? No, it doesn't. I could label this A, I could label this B. And then if I label this one B, this one has to be A. As long as you label them each differently, between A and B, it doesn't matter which one is A and which one is B. Okay? But the hypotenuse is always going to be C. This does not change. This longest side that's across from the right angle is always C. So you can use the Pythagorean theorem to solve a lot of different problems. Suppose you drove directly west for 48 miles. Well, most of you might end up in the ocean. And then you turn south and you drive for 36 miles. How far are you from where you started? And if I ask how far you are, you're not going to calculate going west and then south. You're going to figure out what the exact distance is of a straight line going from where you started to where you ended, or from where you ended to where you started. Okay? So in order to solve this, I don't need a ruler. I don't need anything like that. All I need is to know what the Pythagorean theorem is. Well, notice if I went west and then south, these two lines create a right angle because I'm going directly left and then directly down. So these lengths of 36 and 48 are technically my legs. So they represent A and B. So if I solve this, I can just do A squared plus B squared and figure out what C squared is. So 48 squared plus 36 squared equals C squared. And if I solve this, all I have to do is square 48 first and then square 36. And 48 squared is 2,304. And 36 squared is 1,296. And if I add those together, I end up getting 3,600 equals C squared. Now, remember, when we were solving this, we weren't solving for C squared. That's not our final answer. We're solving for C. We need C squared in order to solve for C. So we're going to take 3,600, knowing that it represents C squared, and we need to figure out what C is. Well, if C squared equals 3,600, how do I figure out the value of C? I have to get the square root. Okay. Now this one's somewhat a more simple large number root that you can get. Ends in 2 zeros, and there's a 36 in the beginning of it, which means that C has to equal 60. Okay. The square root of 3,600 is 60. And again, if you did not know that or you couldn't figure that out off the top of your head, which is completely fine, you would need to solve it out like we did before. 3,600, divide it however you want. It does not matter. You could have done 36 and 100 and then known that the square root of 36 is 6 and the square root of 100 is 10. Multiply these together. 6 times 10 gives you 60. Okay. So what if I gave you a rectangle, a 15 by 8 inch rectangle, and I said find the length of the diagonal of the rectangle? Now the first thing that should pop in your head is, besides the fact that these opposite sides are 15 and these opposite sides are 8, is that every angle of a rectangle is 90 degrees. Meaning this angle right here is 90 degrees. So we have a right triangle. Okay. So if I want to know the length of this diagonal, I can use the Pythagorean theorem. A squared plus B squared equals C squared, and then solve for C. So if I do that, tell you A is 15, I tell you B is 8, let's solve for C. Let's write this one out. So we have 8 squared plus 15 squared, and that gives me C squared. 8 squared is 64, plus 15 squared is 225, and that equals C squared. And 64 plus 225 is 289, and that equals C squared. Now 289 does have a square root. It's not one that you would guess. C equals 17, because 17 times 17 equals 289. So the length of the diagonal, in this case, C, is 17. Now I want you to practice using the Pythagorean theorem to solve this. Try this one out. Pause the video and try to solve this. Even if you don't get the actual root yet, that's okay. All right, so this is a special right triangle, okay? There are specific triangles that have what we call Pythagorean triplets. Some of these you can tell right off the bat. There's some specific ones. For example, the two most common ones are a 3, 4, 5 triangle, meaning that the legs are 3 and 4. That gives you 5. And then the other most common one is a 5, 12, 13. Okay, these are the two most common right triangle side lengths that you'll see. But again, if you don't know that, you're going to solve. We had 5 squared. My legs were 5 and 12. 5 squared plus 12 squared equals c squared. 25 plus 144 equals 169. And the square root of 169 is 13. Try this one. This one's a little different, so be careful. All right. So in this one we have one leg, which is 10. And notice that 26 is not the other leg. 26 is across from the right angle, which means that 26 is the hypotenuse. Okay, so I can tell you that A equals 10. We don't know what B is, and C equals 26. Okay, so if I'm solving this using A squared plus B squared equals C squared, I know A and I know C. This becomes 10 squared plus, we don't know what B is, plus C squared, oops, not plus, sorry, equals, I got too trigger happy with the pluses, C squared is 26 squared, okay? 10 squared is 100, plus B squared equals 26 squared, 676, okay? Now you solve this like you would a linear equation. First thing I'm going to do is I'm going to subtract 100 from both sides. This cancels out. I'm left with B squared equals 576, okay? Remember, to get the square root of 576, or sorry, to solve for B squared, you're going to have to get the square root of 576, which means square root here, square root here. B equals the square root of 576, and we're going to solve for that right now. Let's say we don't know what the square root of 576 is. We can break this down. I can divide it by 2. That gives me root 288. 2 is prime. 288 divides root 2, root 144. I know the square root of 144 is 12. I'm done breaking it down. These two give me 2 times 12 gives me 24. So B equals 24. Okay, which makes sense because remember C is always supposed to be the biggest side. So B has to be less than C. And your answer is right there, 576. Now, the very last thing that I'm going to talk about using the Pythagorean theorem is understanding how to use the sides of a triangle to prove that a triangle is a right triangle or not. Okay? So we're going to be using the Pythagorean theorem to prove a triangle is a right triangle. How do we do that? Well, again, Pythagorean theorem is a squared plus b squared equals c squared. So if I give you three sides, if I give you any three sides, you're going to have to use the Pythagorean theorem to figure out whether or not the triangle is a right triangle or not. So if the formula works, it's a right triangle. If it doesn't work, it's no longer a right triangle. Okay? So I'm going to give you two examples. Here is 10, 24, don't know why I'm writing it that way, 10, 24, and 26 versus, let's go with 6, 10, and 14. Okay. So the first thing I need to identify, because again, my sides might not be in order. Okay, it might not be as easy as A, B, and C. In this case, it is. This is my largest side. This is my largest side, so I'm labeling this C so I don't forget. In terms of the other two, it doesn't matter which one's A or B. So I'm going to do 10 squared plus 24 squared equals 26 squared. Okay. So we've already done this example. 100 plus 576. Oops. Equals 676. 100 plus 576 equals 676. So this checks. This is indeed a right triangle. What about the other side? Well, we have 6 squared plus 10 squared equals 14 squared. We know 6 squared is 36. We know 10 squared is 100. And 14 squared is 196. Well, 100 plus 36 is 136. And does 136 equal 196? It does not. Okay, so this is not a right triangle. This is not a right triangle. On the other hand, 10, 24, 26 is a right triangle. And again, I prove this by plugging in the sides into the Pythagorean theorem. That's it. Those are the basics. If you have any questions about the Pythagorean theorem or how to use it, please let me know. Thank you.